imagine that you are alone, far beyond Earth, far beyond the planets, far beyond the warm light of the sun. Your spacecraft drifts silently through the darkness of interstellar space. There's no sound here, no wind, no up or down, only endless stars scattered across the black ocean of the universe. Behind you lies everything humanity has ever known. Ahead of you lies something very different, something strange, something mysterious, something that has fascinated scientists for generations. At first, it appears as nothing more than a dark shadow suspended among the stars. But with every passing moment, it grows larger and larger, until you begin to realize what you're looking at: a black hole, a place where gravity becomes so powerful that even light can no longer escape. Tonight, we leave the familiar universe behind and begin a journey toward the point of no return. Every black hole begins with a story that starts not in darkness, but in light. Millions of years ago, the object before you was not a black hole. It was a star, a giant among stars, brilliant, hot, and unimaginably powerful. Deep within its core, atoms collided with tremendous force. These nuclear reactions produced enormous amounts of energy. For millions of years, that energy pushed outward while gravity pulled inward. The two forces remained perfectly balanced, a cosmic tug of war. But nothing lasts forever. Eventually, the star began to run out of fuel. The fire inside it started to fade. And when that happened, gravity finally won. In only a matter of seconds, the star collapsed inward under its own immense weight. Then came an explosion so powerful it briefly outshone entire galaxies, a supernova. And when the light faded, something new remained, something invisible, something terrifying, something beautiful. A black hole was born. The name can be misleading. Many people imagine a giant hole floating through space, pulling everything into it like a cosmic vacuum cleaner. The reality is far more fascinating. A black hole is not really a hole at all. It is a region of space where an enormous amount of matter has been compressed into an incredibly small area. The gravity becomes so extreme that space itself begins to bend. Imagine placing a heavy bowling ball on a stretched sheet. The fabric sinks beneath the weight. Now imagine something so heavy that the fabric collapses almost endlessly inward. That is the effect a black hole has on the universe around it. It doesn't pull objects through magic. It changes the shape of space itself, and everything nearby must follow those curves, even light. As your spacecraft continues forward, something unusual happens. The stars no longer look normal. Some appear stretched. Others seem duplicated. A few seem to be in places where they should not exist at all. At first, you wonder if there is something wrong with the ship's instruments. But there isn't. What you're witnessing is real. The black hole is bending the paths of light itself. Photons that once traveled in straight lines are now being forced into curves by gravity. Universe around you begins to look like a reflection in a warped mirror. Galaxies twist. Stars bend. Reality itself seems to ripple before your eyes. The closer you get, the stranger it becomes. and you haven't even reached the black hole yet. Most of us think of time as constant. A second is a second. A minute is a minute. Time feels steady and reliable. But near a black hole, time behaves differently. Very differently. Your clock continues to tick normally. Your heartbeat feels the same. Nothing seems unusual from your perspective. Yet, for someone watching from far away, a different story unfolds. They would see your movements slowing down, gradually, almost imperceptibly at first, then more and more, as if time itself were becoming thicker around you. The closer you move toward the black hole, the slower your time appears to pass. A single hour for you might become days for someone far away, or years, or even centuries. Near a black hole, time and gravity become deeply connected. And the closer you travel toward the darkness ahead, the more separated you become from the rest of the universe. Ahead of you lies a boundary unlike any other in the universe. It has no walls, no color, no warning signs. If you were looking through the window of your spacecraft, you wouldn't see a line drawn across space. And yet it exists. Scientists call it the event horizon, the point of no return. Crossing it is not like hitting a barrier. Nothing suddenly explodes. No alarms begin to sound. In fact, if the black hole is large enough, you might not notice the moment at all. 1 second you are outside. The next, you are inside. But something profound has changed. Every possible future now points in the same direction. Inward, away from the universe you once knew. Away from Earth, away from the stars, away from everything. Imagine standing at the edge of a waterfall in a river. Far upstream, escape is easy. You can swim in any direction. But as the current grows stronger, a moment arrives when no amount of effort can carry you back. The event horizon is that moment, not for water, but for reality itself. Once crossed, every path leads deeper into the darkness. And for the first time in your journey, there is no turning back. As you continue your descent, something remarkable happens. You look back, and the universe is still there. The stars, the galaxies, the vast cosmic ocean. But they no longer appear as they once did. Light from every direction is being bent around the black hole. The sky becomes distorted, wrapped, twisted. It is as though the entire universe has been folded into impossible shapes. You watch distant stars circle around your field of view. Galaxies appear stretched into glowing arcs. The familiar heavens begin to resemble a dream. And somewhere, impossibly far away, Earth still exists. Perhaps people are living ordinary lives, watching sunsets, walking through cities, looking up at the night sky, unaware that you are falling into one of the strangest places nature has ever created. The farther you travel inward, the more disconnected you become, not only from space, but from time itself. The universe continues without you, and with every passing moment, you drift farther from everything you have ever known. Imagine carrying a clock with you. Its hands continue moving. Tick, tick, tick. Everything feels normal. But far away, another clock is watching. A clock near Earth. And the two no longer agree. This is one of the most extraordinary predictions ever made by science. Near a black hole, gravity affects time itself. The stronger the gravity, the slower time passes. For you, only minutes may pass, but outside, years could slip by, decades, even centuries. If someone could somehow watch your descent from a safe distance, they would see you moving slower and slower. Your image would appear frozen near the event horizon, a ghost suspended in time. Yet, from your perspective, the universe beyond the black hole would seem to accelerate. Stars would age, galaxies would evolve, entire civilizations could rise and disappear, while you continued your silent journey inward. A black hole does not simply bend space. It bends the very flow of time, and nowhere else in the known universe does this become more dramatic. The name sounds almost humorous, Spaghettification, but the reality would be anything but. Gravity becomes stronger the closer you move to a massive object. Near Earth, the difference is tiny. Near a black hole, it can become enormous. Imagine your feet are slightly closer to the black hole than your head. Your feet experience a stronger gravitational pull. Your head experiences a weaker one. The difference grows and grows until your body begins to stretch. Not because something is pulling you apart by force, but because gravity itself is no longer equal across your body. Scientists call these tidal forces, and near some black holes, they become unimaginably powerful. Everything stretches, everything distorts, everything is pulled along invisible gradients in space. For smaller black holes, this process could begin long before reaching the center. For supermassive black holes, however, you might cross the event horizon before noticing anything unusual at all. One final reminder that black holes rarely behave the way intuition expects. Now imagine that somehow you survive. Impossible, perhaps, but imagine it anyway. The stars behind you continue to fade. The blackness ahead grows deeper. There are no landmarks here. No planets, no moons, no points of reference. Only a journey towards something no human has ever witnessed. Physics begins to lose its certainty. The equations that describe the universe so beautifully begin to struggle. The closer you move toward the center, the less we truly know. This is where science reaches its frontier. Not because we lack curiosity, but because nature refuses to reveal all of its secrets. For centuries, humanity has explored oceans, mountains, deserts, and planets. Yet here, deep inside a black hole, lies one of the final unknowns. A place hidden behind a curtain the universe may never allow us to lift. At the very center of the black hole lies something that has puzzled scientists for decades: the singularity. It is one of the strangest ideas ever proposed by physics. According to our current understanding, all of the matter that formed the black hole is compressed into an unimaginably small point, a place where density becomes infinite, a place where space and time themselves appear to break down. And that presents a problem, because infinity is often a sign that our equations have reached their limits. Nature rarely gives us infinite quantities. Instead, it usually means there is something deeper we have not yet discovered. Imagine trying to describe the ocean using only a glass of water. You might learn something useful, but eventually, your model becomes too small for the reality it is trying to explain. That may be what is happening here. As we approach the singularity through mathematics, our theories begin to fail. Einstein's theory of general relativity predicts one outcome. Quantum mechanics suggests another. And somewhere between them lies a truth we have not yet uncovered. For now, the singularity remains hidden behind a veil of mystery. Perhaps it is a point. Perhaps it is something far stranger. Perhaps it is a place where our understanding of reality must be rewritten entirely. And so, at the very heart of the black hole, we encounter not an answer, but another question. For as long as black holes have existed in our imagination, one question has continued to capture our curiosity. What if they are not merely endings? What if they are doorways? At first, the idea sounds like science fiction, a passage through space, a shortcut between distant regions of the universe, or perhaps even a bridge connecting entirely different realities. Yet some of the equations used by physicists allow for such possibilities. These hypothetical structures are known as wormholes. Imagine folding a sheet of paper. Two distant points that once seemed impossibly far apart suddenly touch. Instead of traveling across the entire surface, you could simply pass through the fold itself. A wormhole would work in much the same way. A tunnel through the fabric of space and time. A cosmic shortcut connecting places that would otherwise be separated by unimaginable distances. Some scientists have wondered whether black holes could be linked to such tunnels. Could an object enter one region of the universe and emerge somewhere else entirely? Could black holes serve as hidden passageways across the cosmos? At present, we simply do not know. No evidence has ever confirmed the existence of a wormhole, and even if they do exist, they may be far too unstable for anything to survive the journey. Still, the possibility continues to inspire both scientists and dreamers alike, because every great discovery begins with a question. And few questions are as fascinating as this one. Could the darkest places in the universe be hiding secret paths through reality itself? Perhaps. Or perhaps the true answer is even stranger than anything we can currently imagine. The universe has surprised us before, and it may do so again. Now, as our journey slowly comes to an end, take one last look into the darkness before you. The black hole remains silent, unmoving, patient, a shadow carved into the fabric of the cosmos. Throughout human history, we have always been drawn toward the unknown. We crossed oceans without knowing what lay beyond the horizon. We climbed mountains simply because they stood before us. We looked up at the stars and wondered what might exist among them. Black holes are the modern frontier of that same curiosity. They remind us that the universe is still filled with mysteries, that despite everything we have learned, there are questions that remain unanswered, places we cannot yet reach, truths we do not yet understand. And perhaps that is what makes the cosmos so beautiful. Not that it reveals all of its secrets, but but that it always leaves us searching for more. Somewhere out there, beyond countless stars and distant galaxies, black holes continue their silent existence, bending space, slowing time, guarding mysteries older than our civilization itself. And while we may never experience such a journey in reality, we can still allow our minds to wander among these extraordinary wonders, because exploration does not always require a spacecraft. Sometimes it begins with imagination. Thank you for joining me on this quiet journey to the edge of the unknown. Until our next voyage among the stars, may your curiosity remain endless and your sense of wonder never fade. Keep looking up,